model. Stand up. Let your hair down. We have T-shirts like this for everybody. These are exclusive T-shirts. These are not the I am a developer. These are the only OpenShift ones you have to sign up. So, but let me see how many USB sticks I have. Who already got one at the booth? Yeah. Okay. So thank you. One. See, you clapped and all these people showed up. 1, 2, 3, 4, 5, 6, 7. We can start now. I only have 8 total. Fight! Just kidding. We'll try to work something out. I don't know. All right. Let's get started again, shall we? So we can do some code. Yeah? We're good? Yeah. Okay. Okay. So in the beginning, you guys all became certified cloud developers and deployers. You can add that to your resumes. The Citron Pousty School of Cloud Development is the institute which you got that from. Yeah, you're welcome. Now I'm going to make you certified NoSQL developers. Okay? So MongoDB, I'm not going to go into NoSQL databases in general. Is that okay? Just know that MongoDB is a particular type of NoSQL database. When someone says, "Oh yeah, I do NoSQL," that's like a bullshit statement. That's like saying I do SQL. Right? There's a lot of different types. Yeah.
Could you maybe summarize for the beginners in 2 sentences why it makes sense to use Mongo instead of MySQL?
Yeah, I'm going to go through that here. Right in the.
NoSQL, MySQL.
Yeah. Ready? Here you go. Okay. So MongoDB is a document database, right? And by document, I don't mean like Word document. I mean, what you're storing is documents. And documents you can think of is a bunch of attributes and values. You can think of it like a dictionary, right? And just like in Python, you can put an array inside of a dictionary or an object inside. Well, in Python, everything's an object. So you put lots of objects inside of dictionaries. The same thing in a Mongo document, right? So you can imagine, rather than storing things in rows and columns, you're just basically putting in documents for each row. And then you can search along any of the attributes in the document. Does that make sense? I want to make sure that part makes sense. So think of like a JSON document. A JSON document is the same, like a JSON object. You would store that whole thing as a entity in the database, right? And then you can query against any of the attributes that you wanted and values of those attributes. Does that make sense? Okay, so then I'll get to some of the reasons why you might want to use it and some of the reasons why you might not. So here's one big reason. Your documents can be nested, right? So like I said before, a document can have other documents or it can have other things inside of it. So you can avoid normal form, right? And so what that means is, let's say we were doing a social check-in application and you wanted to store all the check-ins with the location, right? If you were to do that in MySQL, you would probably have the user, a whole bunch of other stuff in several separate tables. And so when you wanted to say, show me all the people who've checked in at Europython, you'd have to do a bunch of joins and you'd have to wait for that join to finish before you could return the results. If instead with a document, when I could just insert the check-ins as a complete document inside of the Europython event, right? So my schema might be like Europython event and then a subdocument which is check-ins, and I keep inserting into the check-ins. I say I want to see all the check-ins for the Europython event. I can pull back that all in one request. I say just give me the Europython document and I'll get back the Europython plus all the check-ins because they were stored together. So it's much faster that way, right? That makes, in terms of that, right? What's the drawback to that? If I'm storing your user ID and everything else, if something changes, then it's not going to automatically update because we don't have the foreign key relationship. Yeah.
Don't you think that the non-SQL approach is going back to the network model, the pre-relational data models?
The question was, is NoSQL going back to the pre-relational model, like the network model? There are network-based NoSQL databases. Like Neo4j is a network database. There's object databases. There's a lot of different types of NoSQL databases. Is it a step back in time? That's a long discussion to be had over beers. Or since I'm in Italy, a long discussion to be had over wine. right? But yeah, and Merrick, yes. Here we go. So in addition to hating Python, Merrick has very strong opinions about NoSQL. Go. Over grappa. Yes, we had grappa last night with dinner. How many of you have had, who are not Italians, how many of you had grappa since you've been here? Okay, if you have not had grappa, how many of you, what? Yes, you should have some. No, you didn't like it? No. Well, okay, fine. If you like aquavit,
Up to a certain level you like it.
but you still like it that night, it's the next day that you don't like it.
Only the last glass that is bad.
Yeah, okay, there you go. It's a delicious, what grappa is they take the skins of the grapes. After they've squeezed all the wine out of it, there's still a lot of sugar left, and then they brew alcohol based off of the skin of the grapes and the sugar that's left in those. And it's delicious. I love it. Okay, so the answer to your question is, that's a very long discussion. Some people will say yes, some people will say no. I think Mongo brings other things besides that to the table, which make it not the old model. And all the others bring new things as well. Yes, they're going back to some old models, but bringing new things as well. It's schemaless. So what do I mean by schemaless is, let's say you have a document that is the user, and their passport number. Let's say you start off with the user, and you're not storing their passport number. Suddenly the project manager comes to you and say, oh, we have to store the passport number. I can't believe I forgot to tell you that, but this data is useless without the passport number. You don't have to call up your DBA if you're running in an enterprise system and say, please create a new column for me. And then if there's like a million records, you don't have to wait for the whole schema to update while all those million records add the column for passport number. You just start inserting documents and you have a new attribute called passport number, and it'll just start taking them without you having to change anything. Yeah?
So it's like the database which recently implemented JSON fields and...
Right, except the whole document is JSON. Instead of a JSON field, it's like a whole JSON document being stored natively, right? And so you can still index now off it'd be harder in a database with a JSON field to index off a sub-element inside the JSON. Here you can index off passport as soon as it's added in, right? What's the problem with, yeah?
Schemaless, you mean XML-like?
No, I mean like, there's no, like, you know how you have a database schema as well. So the question was, schemaless, do I mean like XML? No, I mean like, with databases, you have a definite schema for your database.
Metadata is that. Schema is the metadata.
That's right, like this is column and it's this type and all that. There is no predefined schema. You can have your own schema, but it doesn't enforce it, and it won't enforce it moving forward either, right? Basically what you do is you move the schema into your application code, right? The database doesn't care as much about it. So the drawback, this is great for rapid application development, right? Because you can just keep adding columns as you need them. You go back and forth quickly with your project manager and you can do things like that. The drawback to this is, let's say I put passport number in my code. I write out the word passport _ number, and then you work with a Java developer and in their Python code, and they write lowercase p passport, and they do camel case, and they do, like me, this is what I want to do, I want to do camel case, and I'll do the capital N number, so it's 2 different names for the fields. The database isn't going to complain. Mongo won't say, I don't have that field. You'll just have all your documents will have either passport number with the underscore or passport number with the uppercase, and you'll just have 2 separate attributes.
you can use.
I've got to be me. Thank you. I'll be here all week. Don't forget to try the drink. Don't tip the bartender. Yeah.
A little terminology question.
Yes.
You use the term attributes.
Yes.
You mean a semantic tag is not attribute in the meaning of the relational theory, right?
No, not in relate.
A semantic tag like in XML.
No, it's a attribute is like a key in a key value relationship. Key and value. But you can, so that's why I said it's like a dictionary, in that you'll have a key and then a value, and then that value could have other keys and values inside of it. It's more like that.
It's not for semantically categorizing the document.
You can use it. Mongo doesn't think about it. I mean, it does, yes. I guess I'm not understanding as much of your question, but you're saying like semantically,
In XML,
have a tag.
I define tags to semantically categorize
The same way you do in a dictionary.
structure and the meaning of the document.
The same way you can choose to do that or not do that in a dictionary, right? In a dictionary, in Python, you choose your name of your key to give it semantic meaning, or you don't have to. Same thing in here, right? It's the same thing. So any other questions about schemaless? So the point with that, the drawback to that is make sure everybody's on the same page when they're making names of attributes to put into their documents. Because Mongo won't complain. You can create databases, you can create collections, which you can think of like tables, and you can create attributes all on the fly without any changes. Mongo won't complain if you mistype the collection name. It'll just start inserting new data into a new collection. So typos matter with Mongo, and it won't complain to you. Got that? It's very good at fast writes, right? So, but you give up immediate consistency. So one of the things we get out of SQL databases is the idea of consistency, right? Like the ACID, right? Everything's going to be consistent when it returns back to you. And so for that reason, I love that my banks use ACID compliant databases, right? I don't want my bank for managing my money using Mongo, right? That is not what I want. But if I'm doing something like a social check-in service, where it could be that I want Mongo to come back to me and say, yes, I've checked you in, and if my friend is hitting another shard or another replica set and looks to see if I've checked in, and they have to wait 3 minutes, 30 seconds before my check-in actually shows up, I could care less, right? That's not something that needs immediate consistency, and it's more important to me that the database returns back faster and says I'm not immediately consistent. Does that make everybody understand what immediate consistency, what I mean by that? No? So immediate consistency is like when I do a transaction in any of the transactional language, any of the transactional databases, Oracle, PostgreSQL, Oracle or PostgreSQL won't return back to the code until it's updated in all the places it needs to be updated in. Right? Then it says, I'm done. I'm done. Everybody's on the same page. Right? With Mongo, it could say, yeah, I've got your transaction and I've stored it in my local version, but the other versions haven't updated yet. So if someone else hits one of the other databases, it may not show my check-in yet, that I've checked into this place. It may not show that data yet because it hasn't become consistent yet. There's several different levels of consistency within Mongo. What you can also do with Mongo is turn off I don't care. You can say to I don't even care if you've written to local disk yet. Just return to me as soon as you get my message. As soon as it goes into the network stack, return to me, right? And so that's why you see a lot of Node.js developers using Mongo, because you can get extremely fast writes that way. Basically, everything's almost asynchronous. It's like, I'm going to do an async call, and then I'm going to tell Mongo to insert. Mongo going to say, yeah, I got your network request, okay, and it goes right back to Node, and Node's like, okay, we're done. So you can get really incredibly fast write speeds, but you're giving up consistency and data safety. right? So like if it's only returning when it gets the network request, if that database goes out or if that machine goes down, they haven't even been written to disk. They're just living in basically in memory or in the network stack. And so you could lose a whole bunch of check-ins, but who cares, right? So it just depends on what is your bottleneck and what you're willing to give up. Yeah.
Suppose I have 50,000 documents or rows in the database, and I'll need to filter some attribute. How good is the performance compared to relational database?
If you've defined your index as well, it's very fast.
So it's not noticeable.
No, sorry, it's not noticeable. No.
And does it optimize under the hood when it stores the object?
I don't know enough about Mongo to tell you that, whether it does optimization. I would guess it would, but I don't know for sure. We're back? Okay. It's also very easy. It's muted. It's also very easy. What happens if I put it on the top? Does it look, how dorky does it look? Ready? Let's try it the other way. Can you tell? It's like a headband. If I had your hair, I could wear it this way too. All right, let's go back this way. The makers of MongoDB were hitting, one of the main things they did when they were building it is to make sure that it was very easy to do horizontal scaling. So vertical scaling is, I'm running out of whatever, and so I'll just build a bigger machine, right? Give me more CPU, give me more RAM, give me 3 more network cards in my box. That's vertical scaling, right? I make the machine bigger. Horizontal scaling is, okay, this machine's tapped out, bring another machine in, and we'll throw some of the load off to that machine. Keep doing that, right? And that's what we've kind of started to see. Mongo's very easy for doing replica sets and sharding that way. And what I mean by that is it's like several simple commands, and it just starts auto-recognizing itself and sharding out and doing replica sets. So that's one of the advantages that people like about it. It's much easier than setting up synchronization, setting up master-slave relationships in relational databases, right? So it's really good at horizontally scaling. So that's it for Mongo at a general level. Any other questions about it? All right, and you'll see what a document looks like in a little bit. Okay. Now some spatial. Does everybody understand what I mean when I say spatial? Like mapping. So how many of you have used Foursquare? Okay, so we're going to basically build a Foursquare application today. It's also like Facebook check-in, like where you check in, you say I'm at this location, and all your friends get to see. It's all exciting and whatever. So the spatial functionality Mongo currently has is near. So what are things near this point? And containment. And so containment means are things contained within this point? And it's all laid out on these pages right here. Okay? So remember, this is a live presentation, talks.thesteve0.com, and then you go to workshops, and this is the Europython one. So if you want to go to those links later, you can go to those links. Things that are good to know, it assumes the coordinates for your are going to be between minus 180 and 180. Why? Why would that be a good place to assume coordinates are going to come from? It's the Earth, exactly. It's assuming that you're on the Earth, right? And that you're using a latitude-longitude system. But it can actually handle any 2D coordinates, right? We could map the coordinates of this room in centimeters. You know, we could say this was 0, 0. I don't know how long that would be. Let's just say it's 1,000 centimeters by 500 centimeters. And then we could define everybody's position by X's and Y's, those coordinates, and then put it into Mongo and say, who's sitting next to Merrick? And what's the distance of everybody from Merrick, right? It can handle any 2D coordinates. It doesn't care. The difference, though, is if we went to 1,500, then what we have to do is change, when we build the index, we have to tell it the values are going to go between 1,000 and 500, okay? The other thing that comes out of this, though, is it has no idea of projections. So projections are when you take round surfaces and make them flat, right? Which is what you do when you take the globe and you make a map. It's called a projection. Therefore, whatever coordinates you put in are whatever coordinates you get out. So when we're doing these coordinates between minus 180 and we're using degrees, all of your distance units are going to come back in degrees. Okay, so it has methods to handle the curvature of the Earth. We need that on the Earth also because what happens to lines of longitude as you go towards the pole? They get closer together, right? We have this bending. So 1 degree at the pole is not equal to 1 degree at the equator. So if you're dealing with a very small area, like let's just say the town of Florence, distance will stay constant. But if you were doing North Italy versus South Italy, like if you were covering all of Italy, distances will not stay constant. 1 degree does not stay constant. Does that make sense? So you have to, it has methods to handle that. Oh, and there's one other thing here. They also, on that page back there, it also has the formulas to convert between latitude and longitude and kilometers or miles. So there's a formula that they give you that helps you convert between the two. Okay? Because most people think in miles and kilometers, not in degrees. Okay, how do you make it work? You put your coordinates into an array. So this is a location attribute, and then there's an array with coordinate pairs. If you're going to use spherical, make sure you put it in the order of longitude and latitude. Right, so if you're using the GPS units, the GPS in your phone, put it in longitude and latitude. That's it. And then you make a 2D index on the field, and you're done. And then you can ask for all your spatial queries that you want. That's it. So how many of you have tried using PostGIS? Have any of you tried? Yeah, and so it's way more complicated than that, right? So this is the beauty of this, right? Even though it only does near and containment, it's extremely easy to set up. And this near and containment usually handle about 80% of the use cases that most people actually want to do in spatial. Right? So with this very simple setup, you're done. And we're going to be doing this in a minute. So that's it. That's all for Mongo and spatial. Any other questions about NoSQL, Mongo, spatial? Everybody asleep. You're supposed to be drinking coffee. Did you guys drink coffee or did you just eat a lot of sweets? Yeah, a lot of sweets. Everybody's going to take a nap now. All right. So let's look at some code. If you want, this one you can find. It's all up on GitHub. GitHub.com/TheSteve0. Let's go to OpenShift. Right? So there it is. You don't have, and then you just search for Flask. And it's the OpenShift Mongo Flask example. And that's what we're going to be using today. Okay? Everybody got it? Okay. So, let's start with the data. So the data is inside of here. I downloaded all the National Park Service data. It's in parkcord.json. I downloaded all the national park data for the United States and Canada, and I put them into documents. So each one of these rows is a JSON document, or a Mongo document. There's a name attribute, and there's the value. Abraham Lincoln Birthplace National Historic Park. And then there's a position field, PaaS, and there's your coordinates in there. Okay? And that's it. That's how simple a document can be. OpenShift, github.com/OpenShift, and then search for OpenShift Mongo Flask. So this is the data that we're going to import into Mongo. I did it as a JSON document rather than a CSV document because I don't know how to put an array in a CSV document. So, all right, that's our data. Anybody have any questions about the data? Looks good? Yeah? Okay. All right. So then, let's look at the code. Sorry. Yeah. The center of the park or wherever the park building is. It's something within the park. Okay? And it's Canada too. All right. So we have because we're using Flask in Mongo, if I look at the setup.py, you'll see that the install requires Flask, PyMongo, and then markup safe, just to be on the safe side, right? But this is how we're going to, remember when we were doing that Git push before and you say setting up pip, setting up all that, you see all that go through when we did the push? You remember that? You'll see it again. This time during those steps, it's going to pull in Flask and PyMongo, those requirements. So setup.py for now is how you pull requirements in for your Python projects. So if we were going to use NumPy, we would put NumPy here. Right? This will be moving to a requirements.txt file soon enough. It's not requirements.txt right now, but we know that that's a preferred way for most Python developers. Is that correct? People would rather have requirements.txt? Yes? Okay. Okay. So why don't we go ahead and merge the code in? So there's instructions down here. So the first thing we have to do is we have to actually add Mongo to our application. Okay? So let's go back to our terminal. If you're still inside of your Git repo, you can do rhc cartridge add mongodb-2.2. Everybody see that up top? If you're inside your Git repo. If you're not, you have to do --app Python ws. Right? And then hit enter. Right. It doesn't install it. It just fires up the binary, and it attaches it to your user as your user in that same on the same node, and it's assigned to your user ID, so it's on the same gear. Right. In high level speak, you're taking the Mongo cartridge and then putting it into your gear.
One more time, what is cartridge?
A cartridge is a way to add functionality. So if I do this, and I do rhc cartridge list, those are all the cartridges you have available. Right? So you have here's our Python version. 2.7 and 3.3 are community cartridges. I wish it would say that here. We have Ruby, there's Tomcat, but then there's others. So these are anything that says web over here means that you can use this as the primary web language, and you have to specify one of those when you create an app. Then after you've created an app, you can do add-ons, right? So you can do the Jenkins client, you can do MySQL, you can do all sorts of other ones, right? HA proxy, Switchyard, RockMongo, which is so RockMongo, particular to this example, this is like PHP MyAdmin, but for MongoDB. Okay? So it should be done over in the other window by now, I'm hoping. Is it? Yeah. And so what you'll notice is we created a username for you by default. Our instances of Mongo require authentication. A lot of people, when they install Mongo locally or on their servers, they won't require authentication. We require authentication. We give you a password for that user. And by default, we make a database the same name as your application. Okay? This is not accessible to the outside world. The only ports we open up are 22, 80, and 443. And then for WebSockets, we open up 8,443 and 8,000. Okay? If you want to connect to this on your local machine, you could do this. I'm not going to do it now. rhc port-forward. This is basically a shortcut for doing SSH port forwarding. Actually, I can do it now, it doesn't matter. So rhc port forward, what that does is it'll go scan your gear for what services are running on what ports, and then automatically make a port forward from your machine to that machine. Right? On a Mac, because it's got the BSD networking stack, you have to do, I forget what it is, you have to do there's something else you have to do to your host file before this will work. On Linux machines, this just works straight away. Right? So there's HTTPD and there's Mongo. Right? So I can go to, if I now do this, Oops. There's the web page, but it's port forwarded. Right? So I can also do this now on my local machine. No, I won't do it because then I have to put the username and password in and everything. But I could do Mongo from the command line on my machine now, and I'd be hitting the server instance. Okay? That's the same thing probably for Python debugging. When you do Python debugging, does it open up another port? Or does it? No? Java does. Java has a special debug port, so you can actually do Java debugging by doing port forwarding. All right. Anyway, I'm going to kill my port forward. All right. So now we've installed Mongo, right? We now all need to SSH into our machine. RHC SSH. Whoops. If you spell it right, it works. So RHC SSH as long as you're inside of your Git repository. All right, I'm in. Is everybody else in? Yes? It helps if I get some sort of feedback about what, yes. I mean, you know, I can keep asking, but without the feedback part. All right, so the first thing we're going to do, this part is good to copy and paste from the GitHub page. I know GitHub, copying and pasting is usually evil, but in this case it is not. All right, I don't want that one. All right, so what you're going to do is copy and paste. Oh no, it won't work yet. Sorry, get out of your SSH. Control D will get you out of your SSH session if you want. We didn't merge our GitHub code, right? So where we are on the instruction page for GitHub is we're at this line here. You're already in your Git repository. What we're going to do here is this line. Right? And so what we're saying is to the local Git repository, I'm going to add an upstream. I'm going to call it upstream. It's going to be, we're taking the master branch, and it's this URL to add it. So we're adding a remote repository in Git to our local repository. Okay, so copy this line, and then paste it into the console inside of your Git repository. Merrick? Okay, and you should see nothing happen. Is that right? Yeah. Then we're going to do this line. Git pull. The strategy is recursive, right? So we're going to pull everything from our remote. We're pulling from upstream, which we called this one. We're going to merge it into master, and the merge strategy is theirs. At -x/theirs. /x/theirs means if there's two files that are the same, overwrite my local file with the one from the upstream master. And otherwise, just bring it in. So you're going to copy and paste this one. This is going to probably ask you to do a commit statement. Right? Because this is basically the same as doing a commit. We're merging and committing the upstream into this local repo. Does everybody get what we just did there? So here, you can just do :WQ if you want, or you can write something if you want. And then you'll see the commit history of what we just did. All right, so when you're faced with that VI screen, just do :WQ, and that'll get you out of it. And then it'll finish the commit. Okay, and now we need to do a Git push, right? Because we've made our local repository on our laptop the same as the GitHub repository, but we're now going to push that up to our server. So you do, again, Git push. Yeah. And so what we're doing now is taking all that merge stuff and moving it up and replacing it up top. So you're going to see the build kick off again. Yeah, so we basically took the GitHub. So what we did was, while we're waiting for this to go, we had, here's our laptop, right? And on here, well, so here's the gear. Here's GitHub. Okay, there must be multiple talks in there, otherwise, or that guy's like doing magic, right? Or that woman is doing magic. What? It's multiple presentations. Okay, so he's just showing off. Exactly. Every 5 minutes, he's handing out euros. All right, so we had our template app, right? And that was the same to start with. What we did is we took the GitHub application, basically replaced this with our new GitHub code. We basically overwrote everything in here. Anything that was the same, that app is unless you do a git revert, right? Without that, everything's lost. Because if like the application file, the file called application, has been completely overwritten. Because remember that -x, we said theirs. What that means is take this new upstream master and overwrite anything on our local machine that if there's a conflict, it's gone on this local machine. And then we need to get it back up here, and so we just do this, and then that replaces this, and this just becomes the GitHub code up here. Okay? And you remember when I did the -- from code? Remember when I showed that in the command line? What that does instead is, during the creation process, when we're spinning up the gear, rather than having the T at all, it just does a straight git clone when it's creating the gear and puts the code there, and then when it clones it down here, we have the same code base. Right? And in the command line, we could have also specified Python and Mongo, and it would have spun up Python, Mongo, and then done the git clone, and then it would have been set to go. That would have been, but I wouldn't have taught you as much. So today is a teaching day. It's the same way like when you're going to look at my code doesn't have any exception checking. It doesn't do any input validation. So this is not production level code. This is just to get you going with the ideas code. Okay? So it's done now, and you can see here, right, we're actually pulling in a whole bunch of other stuff during the pip stage. Right? An easy install pulled in those libraries for us. Okay? So if you go to your page now, it's broken. Should be broken. I hope it's broken. What? It worked? It says hello world, right, because I rewrote the page as hello world. So now what we need to do, now we can SSH into our machine. Everybody now do the RHC SSH. All right, everybody in? Okay. So now we're going to copy and paste again. Ready? We have to get that JSON file into Mongo. Right? It's not in Mongo yet. But it was in our repository. So if you go back here, you'll see this Mongo import line on the GitHub page. Copy that entire line. And you'll notice it's using, let me go down one font. Oops. Right? It's using environment variables. So that's how I can make it work for everybody, because it's going to use environment variables for username, password. What we're basically, Mongo import is a bulk loader for Mongo. Okay, and so what it's saying, Mongo import, the database is Python WS, which is the same name as our application, the one that was already created. We're going to create a collection called park points. Okay? The import file is of type JSON, and the file, we're pointing to the file, and we're using the repo directory, because we pushed that up with the Git Push. Okay? So we can just copy and paste this, and it may work. I've been running into problems before for certain people. See how it's using the environment variables for everything here? So now I hit enter. And mine says imported 547 objects. Does that happen for everybody else? Awesome. So you just imported 547 JSON documents into Mongo. Okay? Now, are we done? Who said yes? No! What else do we need to do to make it spatial? We have to make the 2D index. So, this is how hard it is to use Mongo on OpenShift. So this is the other reason why I love platform as a service as a developer, right? Like if I wanted to start using Mongo, I'd spend at least a day like reading the instructions, installing it, getting it set up, making sure it was writing to the right places. Here I just add the cartridge and I say Mongo and I'm in. And I can start playing with Mongo. Right? Someone else has already set it up for me. It's running. I know that it's running right. Everything's installed. I didn't have to compile any dependencies. Okay, so you can say use Python WS. Hit enter. So now we're in the database called Python WS. Go back to the GitHub page, and you'll see this line, DB, park points, that's the collection we made. Ensure index on the PaaS field, and the type is 2D. And so that's, like, instead of saying B tree, we're saying 2D, which means make it a spatial index. So control copy, control shift V, or control V, Apple V, hit enter, and you see nothing happen, but you're done. We've just now made a 2D index on our spatial field. We're ready to go with spatial queries.
This is already finished?
Yeah. It's not a very big data set though, right? It's 500, it's just very small, so. But that's how good we are. Was there another question? No? We're all set, right? So, let's see if this part works now. This is the part where they've done a lot of changes recently, so it may start working again. I hope it does. So if you go back to your app, right, it still should say hello world. Does the hello world still work? Yeah? Okay, if you do /ws/parks, right, so let me put that up here again. Oops. So whatever your URL is, URL/ws/parks, and hit enter, what do you see? JSON. As a matter of fact, you're going to see 547 JSON objects. Why? You know, I installed the... Why doesn't it do it? Let's see if it works now. Darn it. I installed the extension that's supposed to make this look like pretty documents in Firefox, and it just doesn't. Sometimes it works and sometimes it doesn't. Anyway.
A little bit about Mongo. I don't think is Python WS is now a database in Mongo, and then
Is a collection, which you can think of as a table. Okay? Tables and collections are about the same thing. Rows and documents are about the same thing.
But still, it's just a namespace, and it doesn't like you can stick any JSON in there.
That's right. Right. So once you're adding rows in, it doesn't care what you put in the row. You're just inserting documents in. And as a matter of fact, you could have totally separate types of documents. Like they could share no field names, but that's not very useful. Right? So what you'll see is there's been a new field that's been added. It's called ID. This is the auto-generated object ID for each document. This is a hash of several different fields. I know for sure it's date, time, and also I think something about the machine that it was generated on. So it's a GUID, but it's also, if you sort them, they're guaranteed to go into insertion order, right? Because it's storing date, time. You can sort on this if you want. It's actually an object, okay? And then there's our old stuff that we had before, a name and the position, right? So there's all our documents. If you are still SSH'd in, which you shouldn't be, but if you are, don't SSH in. Oh yes, you are. You can the syntax for what we just did is db.parkpoints, and there should be tab completion, find, and hit enter, or semicolon and hit enter, and that's the exact same thing we just did, right? That's like select star from in SQL. Again, that was the command was DB, so we're using our database, park points, which is the collection, find, and then open and close parentheses, which means find. I'm not using any selection criteria on it, and hit enter. Okay? All right, so our app is working. Let's walk through the code. How many of you have used Flask or Bottle before? Has anyone used Flask? Nobody's used Flask. Has anyone used Bottle? A little bit? Okay, so the people who've used Bottle, Flask is very similar for URL. I'm basically just using Flask for URL writing here. And are most of you Django developers? Okay, you're going to love me after this because Flask is so much lighter weight and easier to use. So you can use it in other scenarios where you don't need all the framework that Flask brings. So right now I'm going to look at the source code for this. The source code for our web service is all in one file. It's in WSGI, and it's in myflaskapp.py. Right, so here I'll show you what we changed in application. Application no longer contains all the HTML. Right, basically all we say is we import the app as application, that's it. Right. The other thing, we'll go back to myflaskapp.py. So here it is. If you use Flask, you'll need this line for it to propagate exceptions. After about a day, I found this. So I kept getting I knew my app wasn't working and the exceptions were being thrown and I would never see them in the log. And that's because by default, Flask swallows exceptions. Which I guess you'd want to do something with this, like set it to false in production. I don't know. I still want exception. If I throw an exception, I still want to know it. But anyway, basically what we're doing here is, what Flask allows me to do is to take URLs and call certain functions based on the URL that's passed in. Right? So the URL we just called, we use annotations, and we say app, which is the name of this file, .route. If it comes into /ws/parks, call this method or this function, right? And so what this parks does is this part is going to stay the same for every single one of my function calls. Which you could say, well, maybe you should pull that out into another function. I chose not to, just for demonstrating purposes. So we're taking another environment variable. See, I'm grabbing the environment variable here to get my database. I use PyMongo connection to get a connection to my database. Then I say, okay, connection, give me this database, which is the same as our app name, right? And now I've got a handle to the database. Everybody got that? So this is all you need to connect to Mongo in Python, using PyMongo. The Mongo driver people have done a very good job of making it feel like the command line, but still also feel like the programming language that you're working in. So you'll see what happens here, right? db.parkpoints.find, what does that look like? That looks like the console from before. So what's really nice about that is when you're trying to debug what you should write here, you can try it in the console first where you can get better error messaging, see what the results are really like, and then you can just paste it right here without the semicolon. And then you get a result set. And so all I'm doing with the results is I'm making the results into a list, telling it's a list, adding it into a dictionary, calling JSON dump on it, and then turning it into a string. And that's all it takes to get that JSON document back. Right? Yeah?
I don't understand what are you looking for with the find if you don't give it the string that you, like in strings.
Yes. This is the question.
Find a substring.
I'm not doing, no, not in this one. This is the same as select star from table, end of the SQL statement. This syntax is give me the table with every field in it. It's the same in the translation for that into SQL is give me the contents of the table. You'll see those in a bit. You'll see them in a bit. If you want to see what the real restricting looks like, I'll show you that in a little bit. It's the next query. We'll do that. Okay? So, but does everybody understand what's happening here? So basically what I wanted to do was to write a REST web service. Right? I'm a strong believer in the idea that server developers should write things that return code, not HTML, which is why I don't like Django. Sorry. Because Django says I should write HTML. It doesn't have to, but its model is it wants you to return HTML from the server, like compiled HTML. And I don't like that idea. It doesn't always do that, but that's how it wants you to think about the world. And I don't like that idea. I like server-side developers doing data and client-side developers doing view. So that's why I like, you can use Jinja templating with here though too, if you wanted to. It has Jinja templating. Any other questions about Flask? You guys get that? Yeah? Make sense? Everything's good so far? Okay, ready? Let's get back a specific park. So we want a park, right? So here, what we're doing here, same thing, app route ws parks/park now. And this is the way you specify, I want to grab this out of the URL and use it in my code. Right? So putting it in the angled brackets says, whatever comes after /park, I want that variable to be available into my function. And then I'm going to call it the same thing between these two. So you see when I call my function here, onePark, I'm passing in park ID, which matches this name. Right? Same code from before, but now, Moshe, this is the db park points find. I want where the ID field is an object ID, and in the constructor I'm passing in the park ID. Right? Remember I said this is a complicated object. You can't just pass in the string because it's not actually a string, it's an object ID. So that's why we have to say object ID.object ID. We're making an object ID, and what we're constructing it with is the string that is the hashed representation. Everybody get that? Kind of? Am I losing everyone on it? No? You want to see it work now? Everybody ready? Go back to your browser. Grab any of the object IDs you like. I like fossils, so I'm going to pull the agate bed fossil beds national monument ID. Build whatever object ID you want. See, I grabbed this one right here. You need to grab one of these strings after an OID. Okay, so copy that one of those. Then up in your URL, do /park/paste. All right, so there's that. This number matches this number. All right? Hit enter. And you should get back just your park. Correct? So there you go. Pretty exciting, huh? Yeah. All right. We don't have to do that anymore, though. Thank you, though. I appreciate it. But look. All right. So let's go back to the code. So that's kind of exciting, but now let's do the spatial part. All right? So in this one, the URL becomes /parks/near. Right? They're just jealous. Same database connection again, but notice I'm not passing anything in from the URL. There's nothing coming straight from the URL with a string of the URL. But what I am doing is getting query parameters. Right? So connection's the same, but before I can actually do my query, I'm actually saying request.args.get. That's how I get query parameters. Right? And this is why this is not production code. Right? Because what am I doing to it? I'm just casting it to a float and then saying, oh yeah, it's definitely a float. Don't worry about it. I know it's good. Right? So this is, again, not production code. But I get the argument, which is whatever's passed in it as lat, I pass that and I make that into a float. Same thing with long. Right? Yeah, your question? Looked like you were going to give me a question. No? You're good? Okay. Then what we do is db park points find. I'm saying on the position field, I want to find where it's near, and then I make an array of coordinates again. Right? So I'm just like the array that I fed in, long lat, based on the coordinates that were fed in, and the same thing. The result, I do the same thing to the result. Right? So, I'll copy this one here. that's in the GitHub. And so it's parks near. So you can say get rid of the park part. It becomes parks slash near slash no slash. Oops. Right, so I'm using latitude 45.5 and longitude -82. And then you hit enter. And you get back a whole bunch of stuff. This is actually a pretty hard place to figure out where it is, based on the parks. Those aren't very popular parks. I know because I'm American. And I care about maps. So this is I know. Though I'll give you the one that's the biggest hint. Where is it? It's this one. Oops. Sleeping Bear Dunes National Lakeshore is a national park in Michigan. So we're somewhere up near the Great Lakes. Do you know the Great Lakes in the United States? We're somewhere up in that region. You can pass into near. You can say near less than a distance if you wanted to, but by default it's going to go until it fills the query result set and then come back. And the other thing is when you use near, you have now bound your sorting to distance. You can never resort. Once you say near, you can't sort the result set some other way. If you pass in a sort alphabetically or whatever, tough. This is, you can only do it based on distance. The first one is nearest to the point that we passed in. Right? I don't know, where's the position on the first one? 81.6 and 45.23. That's actually pretty close. Right? And so you can keep changing these numbers if you want. So if you want to get to, where would you like to go? First one says a place in the, what? Idaho. So we need to go just west. This is probably just about west. So let's go to like 102. I don't know how many parks in there though. Montana will probably be. Minuteman. So we're now Minuteman and Badlands. We're in North Dakota. All right. So we want to keep going. Idaho's skinny at the top too. I got to go a little bit farther south. Anyway, you can keep, yeah, nice. Good friend you are. You couldn't pick something like Alaska, something big, nice big target. You should have said Rhode Island. Something in Rhode Island. So you can keep playing with those as much as you want. What is this like in Foursquare? This is when you fire up your app in Foursquare. And for those of you who've used Foursquare, you sign in, you start it up, and it usually passes you a result of everything near your location. And so in most of your apps, these coordinates are going to come from your phone. Right? You're going to use the phone API, or you're going to use the HTML5 API and say, what is the coordinates of the phone? You'll get those coordinates, you'll pass them in, and then you'll get a result set back like this. Right? That's how easy it is to do a check-in. For those of you who've used PostGIS, it would be a lot more code to get that up and running. Right? This is very simple and easy to get running for social check-in, and it's relatively fast. But usually when you do this in Foursquare, how good are the result sets? Bad. There's usually, especially if you're in a city, there's a ton of things near you, and they're usually not, and your GPS coordinates in the city are not very accurate, and so it's usually not the thing, it's not in the list of the things you want. So now we're going to write another query that allows you to put in the name of what, because you can use spatial queries in a compound query. Right? So we're going to do a compound query now. So the next example, what do we go to? 30? When are we over? So we have 45 minutes? You guys better think of other things you want to start doing, because we're almost done. We can hack this, we can modify the code together to do an insert if you want. We can do that. Okay, so here we're doing the app route, we're doing WS parks name near name. Right? So we're doing two things with this query. We're grabbing something from the URL, which will be the name, but like before, we're also grabbing the query parameters of latitude and longitude. I'm making a regex. So this is a normal Python regex, right? This is not some special Mongo regex. To write the regex, you write it in Python. If you have Java friends back home, you write the regex in Java. If you have Node.js developer friends back home, you'll write the regex in JavaScript. Right? The regexes all come natively from the language. And then we pass that in, right? So we're doing a compound query here. DB park points find, name and we're doing the regex against the name field, and we're doing the PaaS like we did before. So that's all it takes to do a compound query. Now I always get this URL wrong. So let's see if we can do it right this time. Parks, I need to put a name in here. Name, near, and then I put the slash, and then Ling, I always spell Lincoln wrong, Lincoln, right? And now I'm only getting things with Lincoln in the name. And they're sorted in distance order from that coordinate that I passed in. Right? So usually you're like, oh, I'm at a gelato restaurant. I'm at a gelato place. So you'll pass in the word gelato, and then this would just be gelatos with distance from where you're at. Right? So you can pass in any name you want there if you want. Washington's another good one to pass in. What's another one that... you know what I'm going to do, Mr. Smarty Pants? I got you now. Oh, there's nothing in Idaho. How about, what would be crap? All right, let me see if Sawtooth. There has to be some national, I don't think there is a national park in Idaho. How about Glacier? There's Glacier National Park, and that's very close to Idaho. So I could get it from there. All right? So you can play around with that all you want, right? And you can, if you change the distance, like I could probably get those to sort. If I change the coordinates, I could probably get them to sort differently. So that's it for the reading. The Python example I didn't do the Python example with an insert. We can do an insert if you want. Do you guys want to see what an insert looks like? Yeah, for a record? Okay. Let's see if we can hack some code together. All right, so I'm going to pull up the Java example at the same time just so I can... I took that same example and I ported it to Java and to Node. So if you wanted to see what the code looks like in Node or Java, you can use, they're all up in GitHub. And as the sad part about after using Python and Node, when I go back to Java, I feel like I'm trapped in tar again, or molasses. It's like, oh my gosh, how many different files do I have to write and how much stuff do I have to set up just to do simple stuff? All right, web app. Oh no, it's not there. Java, org, OpenShift, web service, parkws.java. All right, insert should be the last one. All right. So basically what I do with the insert, the Java code looks really basically similar. I make an object, I get my connection, and then I just call insert on that collection. Right? So basically you just have to make a JSON document, or it's probably going to just be, we're probably going to make a Python dictionary, and then just insert the Python dictionary. This here, where's the write concern safe? Remember how I said I could have it just put onto the network stack and return back to me? This says, when you write it to disk, return back to me. Okay? It still won't say whether it's replicated across the entire replica set, but at least I'll know it's been written to one machine on disk. So we have to look up, do you guys really want to do this? All right, I'm not claiming I'm the expert here, so you're going to watch debugging going on, but this will be good because I'll do it in GitHub, and then when it works, or I'll do it here and then I'll put it into GitHub into the code. We'll update the code afterwards. Okay, so let me open up a Python editor. All right, cd WSGI. JEdit. My flask-app.py. All right. So what was the URL syntax I used for the Java one? I also need to look up how Flask knows between a get and a post. No one's really used Flask for this, right? All right, so we need to look up Flask document. Is this really what you guys want to do, or do you want to do something else? Because this is going to be like watching some mediocre coder write code. So, yeah.
I'm interested in seeing how the load balancing stuff works. I'm not using it in years. I'm not very interested in that.
Okay, does anybody else have an interest in seeing load balancing work? Yeah, you want to see it? Okay. I have a Java application that's already running that's set to be a load balancer. Can I do it against Java code? Because it doesn't, the way you do it doesn't change. Is that okay? And it actually uses the same REST web service. So, not this one, the Java version of it. Okay? So let me see if the app's up. Here's what you'll get to also probably see auto idling. Java parks. Let's see if it's been idled. It should have been idled. Okay, yeah, it's idled. So what happened is, see this is Java Parks. This is on a different account that I have, right? And I took that Java version of the web service, and then I built a mapping front end to it. But this time when I created the application, I made it scalable. So what you see now is HA proxy status. The Java server actually takes quite a long time to start up, just because they take a long time to start up anyway. But what we do by default in OpenShift is if there's no HTTP connections, in online at least, if there's no HTTP connections into your application for a full day, we'll idle your application. Right? So we spin it down. We haven't deleted it, we've just spun it down. The next connection that comes in, we'll have to wait while we spin it back up, and then they'll get their HTTP connection, right? And then for the next day, everybody will be fast, but if no one comes in for another day, then we'll spin it back down again. This is why it's really good inside of enterprises as well, because how many of you work in an enterprise company or a bigger company where someone's giving you VMs to do your development work? Yeah, and how many times have you told the person who gave you the VM that you were done with it and they could have the resources back? How many times have you done it? All the time? Are you German? Czech. Oh, that's right, you're Czech again. But Marek has already told me that Czechs and Germans are very close. Yeah?
But I'm also the guy giving them the VM.
So that doesn't count either. But you said you've never done it, right? Yeah, and you never done it. And I never used to do it. I was like, whatever. And then you get that email like a year later, which is like, we're about to resource collect all the VMs. You have 3 weeks to tell us you need this VM or not. You have 1 week to tell us you have the VM or not. We're shutting down all the VM, right? So what happens here is rather than having to have them do that, it'll just get idled. And then all it consumes is a little bit of disk space. So they never have to garbage collect all the VMs because they just get shut down. We just serialize it to disk and shut off the HTTP connection, right? And if you try to SSH into an idle gear, it has to spin up. So SSHing will take longer as well. And the overall server's listening, and that's the key to tell it to spin back up again. With SSH, we shut it down after 40 minutes. So if you SSH in and only SSH in with no HTTP connection, we'll idle it back in 40 minutes, right? And if you're in an enterprise situation, they can tune that to whatever they want it to be. It could be like, oh yeah, we'll auto idle after 5 days. All right, so let's reload and see if it's back, if the server's up now. Yeah, so now it's up. So you can now all go to javaparks-spsummit.rhcloud.com, and that's the same REST web service. I'm using Leaflet with OpenStreetMap to do the mapping on top. Right? So this is a pure JavaScript application using those JSON services we wrote before. So Java Parks, here, let me put it in bigger font. That's the URL. Is everybody seeing it? Is it coming up? So you can, what it's doing is, I wrote event handlers in JavaScript so that on Zoom or on Move, either of those events, it goes and queries again using a bounding box query rather than a point query. Right, so I can do that for my queries. So I basically get the extent of the map and I pass back a query. So as we zoom out, you can see me pulling in more tiles. That actually just happens through the leaflet API, but all the points are coming from my service running on OpenShift. Make sense? And you can see our service is actually really quite fast. Right? Every time I zoom, right, there's a whole bunch of parks coming in. All right, I'll give everybody a minute to play around with the map because that's what everybody likes to do as soon as they... Sorry, it's not in Europe. Otherwise, I know everyone will be looking at their house. Where's my house? What parks are near my house? Forget the parks at all. I'm just going to zoom into where my house is. That's the first thing everybody does. But you can keep zooming around, and then you can click on them and see the name of the park. Right? So that's an example of what you can do with that service. And the code for this is actually very small. That's basically the entire code that I needed to get that all to work. Right, so here, this is the load up code. So basically this is all just loading up the map and putting the copyright message on it. This is getting the pins. So this is get the pins, right? And I call the same, I should be calling this, yeah. So I call get the pins, right? Map.getBounds, that's where I get the boundary of the viewport. Here's the URL. Right, so you can see I've made a new query called within rather than near. I pass in two things, the two corners, and then I call a callback on it, right, with the result set, and the type is JSON. And then function pin the map. I remove all the pins that are currently on the map. Then I make a new array. I loop through all the things that came back from pin the map. And then I make a marker, add a marker to it, and then add that marker array to the layer group, and it puts it on the map. So I say on map drag end, so when you drag and you stop, I call get pins. On zoom end, so zoom in and zoom out, I get pins, and map when ready, get pins. So this is all the JavaScript code I need to do that. And my server-side developers didn't have to think about the UI at all. Right? Oh, and then there's some other code in there because I'm using Google Fonts. I think it comes from leaflet. It's the capital L for leaflet. Okay? So that's all the code. So now, so this also makes it very easy for me to test both pieces separately. So what I'm going to do now is, how many of you have heard of BlazeMeter? Moshe, have you heard of it? It's an Israeli company. No? BlazeMeter? Or it's like Blaze.io. Have you heard of Blaze.io? Basically, these are all load testing companies in the cloud. Right? So I'm going to sign into BlazeMeter. Oops. Also, I'm going to, on this application, I'm going to open up another tab. Right? But I'm going to go to HAProxy-status. And this is actually on scalable apps, this is HAProxy and this is the status page. And I don't understand enough, like I've read the documentation several times, but they don't have very good documentation. What I do know is we are right now running 2 gears. And this is the part that will start scaling up. And these are the metrics that are coming in, right? So I've had 2 sessions, I've done a total of 183 sessions since we restarted the app. Okay? And there's been 131 bytes in and 499 bytes out. Okay? Half a meg out. So now, I'm going to start log in. I think that says log in there. Which login did I use? That one. All right, so I should already have a test that's going to hit that already, but I'll show you what the tests look like once I log in. Okay. So I'll show you what this test looks like. All right. So what you get to specify is where do you want the test to start from. They use Amazon, but you can specify all sorts of different zones. I'm picking East because that's in the same data center as our hosted solution. I'm getting get and post lists and tests, so I'm using normal REST requests. I'm using up to 50 users, okay? The delay between users is 2 seconds. I'm doing extreme stress, which means the load ramps like this. Right, it just goes straight up. They have other ones where it's like a gradual ramp, where it does something like that, right? And then they have a really slow one, which grows over a slower time. But we basically want to watch scaling happen, so I'm going to hit it hard. And so I've got 4 different pages that I'm hitting, right? So I've got the straight parks, which is pulling back all the parks. I'm doing 3 different distance queries as well, even though they have the same name. I just copied and pasted, right? So let's see. Right. But this is not the right one. Okay, I can't use this one. Let's see if this one is hitting against the right one. No. This is actually hitting, I didn't make it scalable. This will hit against my one I currently have. I need to make a new test. All right, let's leave that page open. And add a test. So now you can watch me make a test. This is how easy it is to create a load test. So there's different ways you can do it. How many of you have used JMeter? Have any of you used JMeter? Right, so you can just take your JMeter script and drop it straight in and it'll use it from the cloud. You can do it from Google Analytics or a Drupal. They have plugins for Drupal. I'm going to do a get and post request. Okay? And so I'm going to call this one Java Parks -SIP Summit. Okay, and I'm going to start it in East again. So URLs to test. Where is this one? All right, so we'll do and it was Java Parks -SIP Summit, right? So this is the name of this one. We'll do is all, and then where was this? We'll do a regex. Actually, let me try this one just to make sure that before we go ahead and start it. Yeah, so for some reason that one understood the JSON and made it nice and pretty. I don't know why. All right, so all I need to do on this one is change this. That doesn't look right though. PJs. Do you know what PJs means in English? Pajamas, exactly. I'll leave that one in just like that. Thank you very much. Pair programming. I'll do another one. So this is Glacier. I'm putting a couple different ones in because I actually wanted to make sure I don't just fill the cache and keep hitting off the cache. Does that make sense? Right? Because I think Mongo should be able to cache a lot of these, and I want to keep doing several different queries. So let's do just a straight near. What did the near syntax look like again? Bloop, 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 bloop. There. Over here. Okay. I think that should be enough because we're also all going to hit the app at the same time while it's going. All right, so there. Now maximum concurrent users, 50. Delay between, 2 seconds between requests. And then so here, so this is the ramp for load. This is stress, and that's extreme stress. Right, and that's what I'm going to run. So the server's 5-minute user ramp up, 35 minutes of continuous load. I'm not going to schedule it, nothing else. Save. All right. Saving? Good. Okay. All right, so it's ready to start. We just click start. All right, so then I have to wait for them to start spinning their stuff up. So do you want me to, did I tell you what happens behind the scenes while we're waiting for them to start? Did I tell you already? Okay, so what happens is, so on this what HA proxy is doing, I can get rid of this test. Let me clean up my browsers a bit. So this is one I want to open. I don't want this one open anymore. I don't really need that open anymore. All right, so what's happening is HA proxy keeps watching for the number of incoming connections, and when it hits the threshold that we've set, what it does is it says, oh, okay, I need to spin up a new gear. So we fire off a hook that spins up another gear with Python on it, or in this case with Java on it, rsyncs all the code over, and then plugs it into the load balancer. Plugs it into the load balancer, rsyncs the code, then plugs it back into the load balancer, and starts serving up requests from it right away. Okay?
Installing this is nothing else but just
Dash S. That's it. To set up all this part. And so then what happens is, as more connections come in, it can spin up more gears, right? And then when the connections start to die off, it'll stop connections to that gear and then spin that gear down. Remove it actually, like delete the entire gear without you having to do anything. Right? So let's see how the test is starting to do. No reports yet. Still spinning up. Do we see any connections, like a lot more connections happening on here? The database, there's a lot more going out. I think it started and it's not loading on the page. Do you guys watch the database, the bytes out? See how fast that's loading? Like sorry, I can't get it to go any higher. This is the line that I'm looking at right here. Right? And the number I'm looking at is this number right here. And as I reload it, it's hitting a lot, that's going up much faster than I expected to if no one was hitting it. Unless there's a bunch of people in here playing with it. How about if I go to report? Here we go. So for some reason, maybe it's a new version of Firefox, I'm not getting the... All right, let's reload this page. Okay, so we've now served up 9 megs. Okay, there we go. So we're starting to see the users ramp up. There we go. So green is hits per second. Max users, we're still at 12 users. We've now served up 14 megs of 14 megs. They're not using the website, they're actually hitting the REST service directly. So remember that my website is calling into that REST service that we had spun up, the same one that we had. So these users are instead just hitting straight against the data. Not again, because it's harder to test UI and get it to do stuff. Like I can load the front page, but if I load the front page, it'll cache that data right away. And I can't, because right now what I'm trying to do is make this spin up another gear. So if I keep hitting stuff that's cached, it's hard to get it to spin up because it doesn't need to spin up another gear. The question is, I don't know, given the 512 megs of RAM, I don't know how much it can actually hold in cache. That's what I'm hoping, that we're, yeah. Okay, so we're now up to our 40. We were supposed to go up to 50. I don't know, did I cap it at 35 users? I thought I did 50. We should all start playing with the park now. Start zooming out and that'll generate more requests, right? But the other thing I think you should point out is like, this is just, I think I'm using a medium gear for this one because we were going to use this for our summit, you know, the big Red Hat summit. But that's still like, even with that many users hitting on the back end and all of you hitting on the front end, it still feels really responsive to me. So this should give you an idea about what kind of resources you get with an OpenShift gear, right? Because each time you zoom or you drag, it's executing a new query. Is it starting to get slow for people? Okay. And this is also going to the US too. I can't get it to scale up. Do more queries, you guys. It's not scaling. I need to give it more load. We've done 68 megs. We're basically doing a meg. Every time I refresh, it's about another meg. And we have 23 concurrent sessions. We need more sessions. Why is it not going up to 50? Didn't I say 50? Ah, it's at 50 now. We need to hit faster. Come on, you guys, faster clicking.
The code is too fast.
Exactly. And it's even Java. Surprising. Anything? Ah! What we're hoping to see is another line appear down here. Faster clicking! We're in China now. You're getting paid per click. Stop mining gold and start clicking. All right. I don't think we're going to get it to scale.
Can you run same test twice?
I guess I could run another test against it. I don't know, no, because it probably knows that I don't know. I could try. We're almost out of time though, aren't we? Oh, we go all the way to 1. All right. Yeah, look, so they're all like executing. Nobody's erroring out. Some of them are coming back in like 8 or 9 milliseconds. Some are longer though. So I think at this point it probably doesn't have everything in cache though, because we're doing a lot of different queries, unless it's pulled the entire data set into cache. Come on. Ah, we got one. So what you see happening here, I can't get it to get, sorry for the people in the back, but because I can't get the page to scroll down any further. But you can see we've spun up another gear. And it's red right now, probably because we've spun it up and now we're doing the rsync and then waiting for the server to start up again. Yes. So this was one gear, and now we're spinning up another gear.
So, but it could be possible that this may take like a, I think it could be possible that the Mongodb
So here's another one, like the shared data storage was a problem for us. The other problem for us right now is we don't have a auto scaling up solution for the database tier yet. The first one that'll get it will be Mongo, and we're hoping that's by the end of the year. SQL databases, auto scaling is a very hard issue because you basically have to auto set up replication, which is not trivial, right? So we're working on that problem, but Mongo will probably be the one where we're working on getting 10gen to take over our cartridge. Hopefully they will. And then when they do that, we'll let them figure out how to do the replication and have that auto set up and just go. So let's see if it's up now. Is it still red? Yeah, now it's green, right? So now we actually have 2 gears serving up content right now. So everybody keep doing more searches. Back to work. Stop looking. All right, let's see what, because I just want to see the statistics report change. There. So now you can see, look, so they're both, now we're serving up different connections between the 2 gears. And you can see we're starting to do, we've done already a meg out of the 2nd gear. And there was no beeper that went off, right? I didn't have to stop my, uh-oh, I killed something. So important, that's the beeper for Fedora, right? Okay, Fedora, I know there's software updates available. Thank you. So now, I don't know if I can do it in the 10 minutes. It should do it in 10 minutes. I mean, one of the things that we don't do is we don't auto scale down right away, right? Because there's an amount of flap that'll happen. Like we don't want to, we're sampling I think once every 3 seconds, once every 1 second, no 3 seconds to see if we should scale up. We take longer to scale back down just because once we've already allocated the gear, you've paid for an hour of it. So we don't want to just spin it right back down if we go right below the threshold again, because you might pop right back up again, right? Like it's easier to, and it's faster to scale down than it is to scale up. So we don't want to scale you down too aggressively. And you've already paid for an hour, so might as well keep you up for a little while longer, right? So let me see if I stop the tests, right? So we've got both gears going. Yeah, the data's coming through, right? Okay, so stop the test. Stop. Boop. Terminate servers. All right. So what we should start to see happening here, there. Why do we, what was that? Why did it go red? I wonder if we've autoed. Merrick, have you tried that yet? Yeah, I've tried it before, but I find it interesting that when I just killed all the servers, the 2nd gear just went red. Ah, we killed it. I wonder why we were so aggressive. It shouldn't be that aggressive. Ah, but you know what? It may have been that since everybody stopped clicking and was watching me, it had already decided to scale down. Right? I think we only got it to scale up by being very aggressive and everybody clicking and moving around. I had stopped, a bunch of people had stopped, so it had dropped below the threshold for a while. And so it scaled down, and now it's definitely going to stay down because I killed the tests as well. So no beeper calls, no nothing. Right? It just did it and then scales back down. And I actually, just to your database question before, I think, given the way that databases are good at scaling, most web pages don't do a lot of, well, I don't know. Depends on your app. But a lot of apps don't do a lot of different queries to serve up their data. So as long as you have some sort of somewhat decent caching solution with your database, or the database does a decent job of caching, you'll find that most of your load is actually in the front-end servers, not in the database servers. And so this scaling solution works for a lot of places right now anyway. Right?
In case you have two GIFs, I think they both have the private.
Yes, they both have private log files today. So that, yes, you can somehow, there was buzzing, sorry. Yes, you can somehow, we can give you that information to SSH into either one. And that's the other thing that we're working on. Like, so here's the other thing. Because we have these large enterprise customers, most of the questions that you're asking are coming exactly from our large enterprise customers as well, who pay big euros or dollars to make sure that they can do these things. And so things they're driving are things like shared disk storage, shared log maintenance, high availability, right? Like all that stuff, all those improvements, there'll be more improvements coming in that area for sure. At this point, we see a lot of alignment between what online users are asking and enterprise users are asking for. So, all right, so I'm done, basically. There. And so these are the rest of the things. A lot of us hang out on IRC. If you do IRC, we're on Freenode, we're in OpenShift. If you actually want to hack on, if you, for some reason, like Ruby, and you want to hack on OpenShift itself, it's OpenShift-dev, right? And that's where you can talk to all the developers. Like, those are the ones who actually build the platform. This one's more for users of OpenShift. And users is the email list, and dev is the developers. So if you have some low-level question. Okay? Thanks, everyone.
Thanks again.
Sure. Oh, and one other note, I'm giving this basic same talk at 2:30. I think it's the next session. After lunch, it's 2:30, right? Is the first sessions? Yeah, so don't come to that, because you'll be bored. Right? It's basically going to be all the same slides without all the hands-on stuff.